I think that Yves Laurent's point that affordability, adequate housing, enough housing is a global problem, and the point that the solutions need to be different depending on whether you're in the global north, global south, and then on a country by country basis is a very good point. And we're going to be talking about some of that today. We heard it in the initial session, and I'm happy to welcome to the podium Ryan Kolker, who's going to speak a little bit about some of the solutions that have been adopted in the United States and beyond to address the affordability crisis and the housing crisis in the United States. Ryan is the Executive Director for Energy, Resilience, and Innovation at the International Code Council, and I'll turn it over to Ryan. Thank you.
Great, thanks so much, and really do appreciate the opportunity to be here. You can go to the next slide. I'm going to talk a little bit about, also important to note, we do have a Slido for folks that are online. If you have questions, we will have a panel Q&A discussion later, so you can capture that. I want to talk a little bit about some of the solutions that we've seen within this space, but first let me give you sort of a quick introduction to the International Code Council and why we're particularly interested in these issues. So ICC is probably best known for the development of model building codes and standards, which support many of the things that Yves Laurent talked about relative to energy efficiency, resilience, sustainability. And you know, we recognize that to make those codes and standards effective, you need the tools around them to support a broader ecosystem that helps on the implementation side. And so ICC really supports, you know, sort of all of those pieces. You can go to the next slide. And so, you know, as we look at the opportunities or the needs across the industry and across society, we really identified offsite construction as an opportunity to address many of those challenges. So if we think about sort of speed of construction, you know, having a factory-built system at the same time that you're doing the site work, you know, sort of speeds up that process. You can also be very deliberate about sort of how you engineer and fabricate the systems. We're also dealing, particularly in the global north, with challenges of the availability of a workforce for the construction industry. And so if you move elements of the construction process into the factory, number one, it becomes more efficient, but number two, you can attract much more diverse workforce. So if someone's going to the same site every day, they know their hours. I have a colleague who says it's always sunny and 75 in the factory, 75 degrees Fahrenheit. You can also be more deliberate about how you use materials. Because you're a very engineered system, you could be more effective about reducing waste. Being in the factory also helps support quality because you're not out in the rain, the snow, the elements. So materials are, you know, much more, are not subject to sort of spoilage and those sorts of challenges. Additionally, you have sort of the job site safety elements of offsite construction as well. Because, again, everything's done in the factory, you don't have the challenge of, you know, for on-site projects, having lots of tradespeople in the same space at the same time, climbing up ladders and sort of working on top of each other. And so you can go to the next slide. To really support the development and the implementation of off-site construction, ICC has developed a suite of standards that focus on the process for approvals of off-site construction elements. So how do we assure that what's actually landing up at the job site is achieving the standards, the codes, and requirements that they need to meet? You can go to the next slide. And so, you know, with sort of that quick snapshot of offsite construction, you know, as a strategy, we see that as an opportunity in many different places. And so we have a team from southern Brazil that have actually leveraged offsite construction to support housing in disaster recovery. And so we have a recording of their presentation. and I'll turn it over to the video now.
So, hi everyone, I'm Daniela Viana. We are going to present the work leveraging innovative approaches to deliver resilient and climate responsive housing. It is part of the graduate program in civil engineering at the Federal University of Rio Grande do Sul and comes from our research lab called Modular. Our main effort has been to create a path toward a more industrialized construction sector. Doris and I are the professors leading this research field. Guilherme will present his PhD research program, and Bruna will share an interesting example of modular construction from the company CMC Modular. We operate at the interface between construction management and economics and building materials and technology. You can learn more about our lab through the QR code. Our research began within the Construa Brasil project and aimed to propose guidelines for developing and refining technical standards that encourage the use of modularity and modular coordination. We have been working on the development of resilient standards to encourage more companies to adopt platform-based solutions, making modular construction more feasible and scalable. Now I leave the path for Guilherme.
Hi everyone, I'm Guilherme from UFRGS. In April and May 2024, our state, Rio Grande do Sul, in southern Brazil, faced a record-breaking flooding event that was considered the biggest hydrological disaster in Brazil history. Around 2.4 million people were affected in 96% of the cities of the state, as shown in the pink and blue areas in Map 1. Around 146,000 people were displaced from their homes. Map 2 shows the concentration of households affected in the state. Map 3 presents a closer look to the Guaíba Lake drainage basin. In red, you can see the flood extent compared to the water body's original extent in blue. In the upper right side, you can take a closer look in the city of Canoas and its affected homes. Societal resilience is a society's ability to anticipate, absorb, adapt to, and recover from such events, leveraging the people, institutions, infrastructures, and communities in order to maintain the essential services needed. In this event, shelters provided temporary housing for the displaced. The number of sheltered people in the state peaked at 78,000 people on May 12, 2024. Previous stressors also played a detrimental role. The most affected people in the metropolitan region of Porto Alegre, our capital city, were also the ones that had the lowest average incomes, as shown in the map on the right. To this day, thousands of families still wait for a new home in Rio Grande do Sul. Addressing temporary and permanent housing needs of the people affected support societal resilience and society's ability to bounce back better. Housing provides a sense of place and should meet social and emotional requirements of the individuals both in the short and long terms. In COP30, human mobility was recognized as a form of adaptation to the effects of climate change. Climate migrations, planned relocation, and displacements are expected to increase in the next decades, requiring suitable solutions to address housing needs and supporting societal resilience.
Hi, my name is Bruna, and I'll be here to showcase our first 25 homes delivered in this southern Brazil after the floods. These were 25 homes built in Nova Brescia, the city of Nova Brescia, and each home has 50 square meters of living space, and each one fits into a one truck load and can be easily assembled on site. And this was the first phase. You can change, please. This was the first phase of a larger effort from local government and private companies to rebuild the homes and families for the families affected by the flood. And our system has been proven and tested for many years. After many years in different sectors such as mining and other infrastructure sectors such as hospitality, where a high base construction is needed. So for us, delivering a high quality and structurally sound home was very important. So here you can see some of the pictures of the houses being built at the factory. You see the construction happens at the same time as production in the factory, and that overlap can save up to 30% of total construction time without losing any quality or scope. We chose to combine 3D modular and panelized modular systems to provide families with a hassle-free home, so that means low maintenance and durable over time. Please change. So normally this kind of public housing project can take months to get through all the paperwork and permits needed. And that's why modular was a key solution to speed up the process. So these homes, as you can see, they look very similar to traditional build, but they have a very low carbon intake, and the system is very flexible in terms of architectural design. Please change. And this is just a great example of how modular construction can bring innovation and speed and low carbon impact to residential building, because we're not just building homes, we're actually rebuilding lives. So here's a quick video of how the system works.
Thank you for your attention, and we are open to your questions.
Thanks so much, and I'll turn it back over to Judy.
Thank you to Ryan and Guilhem and the whole team from the university. That was really interesting, and it's interesting to see similar solutions being employed in the global north.